If you enable your clients to start long-running tasks via the API, you should make sure that you don't block your clients, but you might at the same time want to expose some information about how the background task is running. And you might also enable clients to cancel a task that has already started. I show you how to do this in this video. Before we dive in, according to the recent data, 87.9% of you who are watching this are not yet subscribed. So if that is you and you get any value out of this video, please subscribe. It helps the channel more than you would know. Thank you. And now, let's code. For this tutorial, I prepared a very simple Spring MVC application that we're going to refactor. So let's start with our controller. Let's assume we have a REST controller and that has one endpoint where we can start a long running task. And I have a marketing service here. And if we just take a look, we can see there's one broadcast operation. And the idea here is that this service is sending out a lot of emails, so it might take a bit of time. And to simulate this long-running task, all this service is doing is really just iterating over this range and then sleeping 10 seconds per run. Now, what happens if we just use the service as is? If I start the application and we go to the terminal and use HTTP post 80 and then broadcast start, what we can see is that this request does not return, right? But if I check the logs, we can see it says starting broadcast because I have the log statements in here. It says iteration 1 finished. So if I go back to the terminal and just cancel the request, then there's no feedback whatsoever. And even worse, the job is still running, right? So I have to really kill the application here. So let's refactor this. And the first question, if you have these long running tasks, is do you need to provide some feedback at all? And if the answer to that question is yes, you should model these tasks as first class entities on the API level. So let me show you how to do this. So let me create a new file. We call this tasks, make it a file. I want to have a representation of a task that is running. So a task for me has an ID. I make this a UUID and we can just generate that when we create a new instance. Then it needs some means of progress. I make this an int and we set it to 0 initially. And this should be the progress in percent from 0 to 100. And I also wanted to give a task a state. And since we don't have that, let's create an enum for that. So there's an enum class. And I call this task state. And then we have created, running, completed, and canceled. There can even be failed or more states as you see fit. But for me, this is really all this task state. And this is created initially, right? So whenever we create a task, it gets a UUID, the progress is set to 0. And the task has a state created. So I'm going to use that to model the current task that is running. But I also want to model different operations in the application because I want to have an event-based approach. So I would go and create an abstract class and call this operation. And the operation has a task like this. That's correct. Now down here, I could just create individual operations. So I create one for broadcast and we say this is an operation. So why am I doing it like this? Because I want to have type safety. First of all, I can use the broadcast and now extend this class to carry more properties that may be relevant to that specific operation. And since I'm going to use the event-based approach, I want to make sure that all these events are type safe as well. Right? So this is the first thing. We model tasks and operations. So what are we going to do with them? So I will create a service and let's create that first. I call this task service and this is a service. And this is the single service that is responsible for managing the state of individual tasks. Now, a few things. In a real world scenario, we would probably plug in a database at this point and store the tasks in there. But I just want to keep them in memory to keep this simple. So I'm creating a concurrent hash map, because multiple threads eventually may be able to access our tasks. So we store a mapping from the UUID to the task. And now we have the basic functionality here. So if someone wants to get a task, then they will do so by ID. And we can return tasks ID here, but we will also now have individual components submitting tasks. So eventually our REST controller will submit a task here. And what does that actually mean? So we will have a function submit. What clients are submitting are the actual operation first, and we manage the task based on that operation. So I'm using a concurrent hash map, which makes sure that concurrent access to that map is already properly synchronized. So I can say tasks. And I'm using compute if absent the ID from the operation task ID, because each operation has a task, and we put the task, right? So this is just how we add it to the map. And here's what I want to do now to have a loose coupling in the application. I can ask for the publisher. I'm using the application event publisher from Spring. Check the video linked above if you need a refresher on how it works. But what I can do now is I can actually publish the operation. So I don't return the task here, that's fine. So that means we put the tasks into the map, so it's managed by the service, and then we publish the event further down into the application. And now what we need to refactor is our service to make it a listener for that event. So I add the event listener annotation here, and we can add for the operation, and that should be the broadcast operation here. So I can make this even specific, broadcast. So this is waiting for the broadcast operation to be sent via the application publisher. And I also want this to be asynchronous because it's a long-running operation. It doesn't make sense for it to be executed synchronous. So we have to go to the application and enable async, otherwise it will not work. I've done this now. And finally, we can go to the marketing controller. And now this is no longer a synchronous call here. And it doesn't even need access to the marketing service because it doesn't even know that there is the marketing service. What it needs is get access to the task service, which is now the single source of truth. And we can just say task submit new broadcast. So this is sending the broadcast operation to the task service directly. This will just store the new task and then publish the event to the other parts of the application, which then run asynchronous, which means our marketing controller will just return pretty quickly. Now, what we're going to build next is a way of updating existing tasks. So let's go back to the task service, and we need a few methods to change the state of a task, right? Again, the concurrent hash map already synchronizes access to itself, but I could still mess with an existing task. So if I have multiple threads, they would just leave a task in an inconsistent state. So I'm using the compute methods on the map. So let's have a start function, which is start ID UUID. And that's just task compute if present, because we need a task for this to succeed actually. What we're doing here is we're using the copy function from the data class in Kotlin, which means we're just swapping the existing task. We create one, so it's all immutable, right? If we go to our task, you can see all the properties are immutable, so I cannot change that task. But what I'm doing instead is I create a copy of the existing task and add it to the map and remove the old one, right? So that way it's perfectly accessible by multiple threads. Let's also have a function to report progress for a task. So the progress is here. There we go. Compute if present ID. Task copy progress, that's correct. Fast forward, let me just add two more functions. The first one is cancel, because we want the functionality to cancel an existing task. Then we need a way to figure out if a task is already canceled. That's relevant for our services. And we need a way to mark a task as completed, right? We're just changing the task state here and here and here. Here we update the progress, here we're changing the state. And that's really all. So if we go back to our marketing service, again, that is sending out these large emails in our scenario, we can just optimize that a little bit. First of all, this service needs access to the task service. And then what I would do is this says starting task. And now we have the operation. Where is it? We have the operation task ID. And now we update the state. We just use the task service and say task start operation task ID. Now the state has changed to running. And in here, in each iteration, what we can do now, we can check if the task is actually active. So tasks active operation task ID. We check if the task is active If that is the case, we do the actual heavy lifting, which is just waiting in our scenario, right? Or sending a batch of emails in a real world scenario. Then we update the progress to be actual times 10. So we always make 10% progress with each iteration. We copy this back up here. So we can log, okay, current iteration has finished. Otherwise, if the task has been canceled, it has been canceled here already, so we don't need to invoke that. We just log task canceled and we return, because then we should stop running this actual task. But assuming that all goes well, we have to set it to complete eventually once everything's finished, right? So what have we done here? We get this broadcast operation. We just start the task. We check if the task is still active because it might be canceled in the meantime. We update the progress and eventually we mark it complete. Right? So this is now all wired up. So now we need a way to expose tasks as first-class citizens on our REST API. So what we can do is we just create a new task controller. This one's a REST controller. And here's what it does. It needs access to our tasks, private val tasks, task service. And we offer a few endpoints. First one is a get mapping to get an existing task. And we can do this as follows. Fun get the path variable, which is the ID. It's a UUID, and we just invoke tasks get ID. So I just pass it from the service to the HTTP layer. And then I want a delete mapping because we want to delete an existing task. So it's not deleting really, it's cancel. Same thing, it needs the path variable, which is the UUID, and then we just call task cancel. The missing piece is now, as you recall, we have our marketing controller that is now submitting the operation. How do we inform client of where they can find the task? And this is also easy. We store the reference to the broadcast here and submit this one. And what we return is a response entity. We return OK with the location header set. So we create a new URI from a string. And this is what we do. So here we set the location to point to our task controller. So this is the task ID. And now we need to build it. It's void. Now I have to add it as a return value. Now I can remove void, and there we go, right? So we keep track of the actual operation. We then submit it to the service. And now we return a result and point the location to where clients can find this task. So let's actually run the application or start it. Let's go to the terminal. If I just now start a new task, what we can see is the request immediately returns and we get a location, right? So if I just copy that location, and right now I'm going for 8080, we can see it's running. We can see, okay, state running, progress is 20. Let's check the logs. Yeah, that's correct. Iteration 2 has just finished, right? This is where the 20% are coming from. Now iteration 3 has finished. If I just now request it again, we see 30% and it has been updated. Now actually, let me delete the whole thing. So we're using HTTP delete, and then it's 8080, and I paste this again. We can see that I made a mistake because it says method not allowed. And the reason is I forgot actually the mapping. So let's go back, because that's also for tasks/ID. Let's kill the application and try this again. So back to the terminal, clearing things up. We have to again start a new task. So HTTP 8080 task, there we go. 10%, it's running. If I now do it again, it's at 20% already because it was running in the background. Now let's delete the whole thing. So it's HTTP delete 8080 paste. And we can see that has succeeded. Now let's check the logs. And here we can see it. If we scroll over there, it says iteration 4 had finished and now the task canceled. So it stops doing the broadcast in that scenario. Now if we check the state of the task again, what we can see, it stopped at 30% progress and it has been canceled. And this is how you actually can model long-running tasks on the API level. If you got questions, please drop them in the comments down below. As usual, I hope that was useful. Please subscribe and I'll see you in the next one.